Hello guys, so today we're going to look into solving this problem, couples holding hands. So there are n couples sitting in two end seats arranged in a row and want to hold hands. The people and seats are represented by an integer array row, where row I is the ID of the person sitting in the ith seat. The couples are numbered in order, the first couple being 0, 1, the second couple being 2, 3, and you guessed it right, the third couple will be 4, 5, and so on, with the last couple being 2n minus 2, 2n minus 1. Return the minimum number of swaps so that every couple is sitting side by side. A swap consists of choosing any two people, then they stand up and switch seats. So we're going to look into the examples which have been given here. So just to write it out, 0, 2, 1, 3. So according to the question, what you need is to have 0 seated next to 1, 2 seated next to 3. So as we can look at this, there is a mismatch whereby 0 is not seated next to 1 and 2 is not seated next to 3. So what will we do? We will have to swap 2 with 1. How do we do that? So 0, 1 will be swapped with 2 and then 3. So this is after one swap. So after that, we'll go to the next one and check 2. Is it seated next to 3? Yes. And then that will return 1. So that is why we only need to swap the second person with the third person. So according to the third example, or to the second example, 3 is supposed to be seated next to 2. Is it correct? Yes. 0 is seated next to 1. Is it correct? Yes. So there will be no swaps. All couples are already seated side by side. So how are we going to do this? First of all, we're going to just introduce a dictionary of the couples so that we'll have a way to easily look up the position of each individual. So we'll initialize first of all a couples dictionary or a couples hash map. So in Python we'll just call it a dictionary. So how do we do this? Couple I for I, couple in enumerate row. Okay, now we have a hash map of the position and the couples in each position. So next we will initialize or introduce an integer swaps, which will keep count of the number of swaps which will be taken after each swap. So after this is done, we're going to look through the individuals in the rows, and since there are n couples, we are going to look through the rows while incrementing them in 2. So how are we going to do this? For I in range start is 0, end is the length of the row, and then we're going to increment it by 2. Okay, yeah. So once this is done, we're going to look into just finding out who is the first couple. In this case, it is the person at the ith index. So how do we find the next couple, the expected next couple? So the expected second. So we're going to name this expected second couple, who will be so how do we do this? Just to think out loud, we can actually check, because 0 expects there to be 1 next to them so that they can be able to hold hands. If it is 1, they expect to be seated next to 0. So if a number is divisible by 2, or if it is an integer, an even number, we're going to add a 1. So we can do that by just checking if row I is divisible by 2, or if it is an even number. So we'll do modulo 2. We are going to say this is equals to first couple plus 1, else the expected second couple is equals to first couple minus minus 1. Okay, but actually this is a bit more complicated, and it actually takes a lot of more logic. To do this in a simpler way, what you're going to do is just to use a bitwise operation. I'll just comment this out for now. The expected second couple is equals to, so we'll do a bitwise operation, since a bitwise operation actually does that in a simpler and more efficient way. So once you know the expected second couple, we're going to check if the person or the individual in the next index, which is row I plus 1, is equals to the expected second couple. However, in this case we're just going to say if it is not, or if the expected next person is not equal to the expected second couple, then we're going to do a swap. So if we do a swap, how do we do a swap? We're going to row I plus 1 is going to be changed with we're going to first of all just get the position of the expected second couple, the position where they are. So how do we do this? We're going to go to the couples dictionary. Is that what we named it? Yes, couples dict. Second couple, just name it second couple. Couples dict expected second couple. Okay, so rows second couple. Then you're going to swap these two. How do we do that? It's just a matter of doing this as second couple row I plus 1. Now once we do this, the next thing is to actually update the position of the individuals in the hash map or the dictionary in this case. So how do we do this? So we're going to just select let me just couple dict, then row, then second couple, and then we're just going to update this to row this is supposed to, yeah, so this is supposed to just update it to the second couple, and that is pretty much it. So let's now return the swaps and test it. Let's just go through it to see if there's anything we've missed. Okay, we loop through. We can actually delete this to just avoid some dead code. Yeah, so let's see if there's anything we've missed. We used rows instead of row. Okay, yeah, now let's run it. Good. Now from my expectation, this should be correct, so we're going to submit it and see what comes out of this. Good, and this actually works. So as you can see now, the complexity of this is actually in the order of n, because there are n couples, and you're looping through the row, counting each item in twos, so that is a couple has 2 items or 2 individuals, and so on. And yeah, and I think this actually helps us beat 16.46. Okay, yeah, so let's just submit it again to see what happens. Yeah, actually, yeah, this is an issue with the lit code. Sometimes this happens, so you can see we took 0 milliseconds and we beat 100%, and this is actually pretty okay. So thank you, and I hope you enjoyed this. Kindly like and subscribe to LD Talent.